So this is the example for basically the power function. And we saw this in a slide before, but here we're gonna actually like walk through. So this is actually with Professor Su originally, some time ago. Okay, so let's actually look at the C++ first to see what we are doing, and then we can basically start a translation. So here, the whole idea is that you have a function that is pow, and you give it two numbers. And it's gonna basically do x to the power of p. So that's what it calculates. So for example, if you give it, let's say 2 and 4, it's gonna give you 16, because that's gonna be like 2 times 2 times 2 times 2. Basically, that's what it's calculating. So that's this pow function. It has two arguments, so that's a two number. The way it does, it's gonna take basically start with 1. So let me annotate. Okay, so it's gonna start. So that's your result. Let's say first it's gonna be 1, and let's say here you are giving it 2 and 5. So it is going to start from 0 to arg1, which is the second one, and it's gonna loop. So it's gonna do this loop that many times. So if you give 5, it's gonna do this loop 5 times, basically. And every time in the loop, it's gonna multiply your result or your product that is started with 1 times the arg0. That is your base. So the first time gonna be basically 1 times 2. So you're gonna get 2. Then the second time on the loop, you're gonna get 2 times 2, which is 4. Then you're gonna get 4 times 2, 8, and then 8 times 2, 16, 16 times 2, 32. So basically, it's a power function. It's gonna loop that many times, and then every time it's gonna times another base to your product, and then it's gonna return the product. So far, so good. Okay. Yeah. So on the main code, we have so these are basically some numbers that we're going to run through this function. And we have a result. So that is shared, you see. And every time we are just calculating that, putting in the result and do a cout. And then another time, and then cout. So if you, I think I have a page open that's running this. Yeah. So if I run this, so that's the same code. We're gonna see two numbers. So that's basically the first one is 3 to the power of 4 and 5 to the power of 6. I like to do a simpler one. So 2 to 2, for example, and then 3 to 3. So you see 2 to the power of 2 is 4. 3 to the 3 is 27, which is 9 times 3 is 27. So basically that's what it's doing. So now let's look at the translation, and we can walk through this. Is it this one? Okay. Okay. So first thing, you want to basically have these numbers that you're using. So we are putting in S registers because if you are calling a function, so here I want to review actually so what is the rules for calling a function, the conventions about the registers?
You need to allocate space, and then you need to have the pointers, and then on the way out.
Okay, so
yeah.
So you're talking about the saving things on stack.
Yes.
Correct. So you don't need to always do that, right? So a function. So this is basically like the convention. If a function, So if you are writing the function, because there's two roles, right? There is one role that you're calling a function, and the other role is that you're writing a function. So here we are doing both. But if you're writing a function, you can change anything. So as a function, you can change almost anything. So you can change the V register, you can change the A register, you can do the T, you can change, we are not talking about these, you can change the stack pointer, of course. So you can basically change all of these freely without worrying, right? So you have that right. If you are if you want to change S registers for some reason, if you want to change that S register, then what you said is true, that you have to save that to stack and then put it back to stack. Sorry, put it back to the S register. So you should restore. Store S registers. So that's basically the two kind of conventions that you have. And we have two cases for the functions. There are either leaf function or like, let's say, non-leaf function. If you are a leaf function, that means you're not calling any other function. So if you have your func, you're doing some stuff, you don't have this jump handling, you don't have that. So that means you're a leaf function. So that's the easier case. If you are not doing that, you are not worried about the return address. If you are a non-leaf function, you are doing a jump and link, and because you are doing jump and link, you are changing this return address, this RA register. So that means then you have to save RA also on your stack. So basically that's all the rules that we have for as a function. Does that make sense? No. Okay, I take that as a yes.
Oh yeah, no, that was a yes.
Yeah.
Yeah.
Okay. And then what is the other side of the story is that you're calling a function. So let's say you're in main, and then you have jump and link, and you're calling this function. So if you just look at what I said, so the function can change A, the function can change V, they can change T without restoring them. That means if you have A, let's say V, T, and well, of course, return address, because this is gonna change it. But if you have these before the function, here, after the function, they're gonna change. So I mean, again, it depends on the code, but you want to write kind of like universal code that works everywhere. So you might have a function that you say, okay, I'm not changing any T register, but that's kind of an exception. If you want to be safe, because later you could go and adjust that function. You don't want to check like all place in your code to see if it's actually depending on that fact. So if before your function you have these, after your function, you don't know if these are exist anymore or not. They could be changed. If you have S, that's gonna be saved. So this S gonna be safe after and before gonna be same value. So that's like the key thing in here. Okay. So that is why we are putting these numbers on the S registers, because we just want to be sure that, you know, the function is not gonna change them. Like we need these values. So far, so good.
Yeah.
Okay.
Yep.
So we have these, and then we are as a function. So let's say you have this function. We can like look at it later, but just as like looking at the header of the function, it tells you that A0 is for the basically arg1, and A1 is for arg0 and then arg1. And I like to call this one like base and power. So it is like actually base or power, something. I mean, but anyway, so it tells you. So the person who designed this function, which is again you know that the base goes in A0 and power goes in A1. You should use A register, but like what if the order, you know? So there are things that like still you need this kind of header to know what you have to put in your function. So because of that, now here you want to call this function. So this is very straightforward. All you have to do is to put your S0 and S1 into A0 and A1, given that you want to do 3 to the power of 4. So after putting that, you do jump and link and your function, and then you have, so at this point, it's gonna run and it's gonna come back here. So now so again, maybe looking at this, you see the return result is in V0. And that's a convention. Again, the return is always in V0. But you could have maybe like 2 returns. So do we have V0 and V1? But so you want to kind of like to know what, double check that. So we are putting that, saving it in another S registers. And we didn't use S2 here, it's 0, 1, and then it's 2. So we are putting that in S2. So that's gonna be basically S0 to the power of S1. So we save that. I want to, before I continue, I want to actually show you on the, let me cut this one. And I want to show the execution. So if we go maybe one at a time. So here you see we are initializing, it's 4. Maybe remove this one also. So we are putting 4. We are putting 5, 6. We are putting them A0 and A1. So you see here A0, I think one more, and A1 are changed 3 and 4. And then here we had the jump and link, which I didn't see that. Here, jump and link. So you see that it actually goes there. And the RA is updated. So if I go back again, I just want to look at that, only that one. If I go back all the way, you see RA is 0. So as soon as I hit that jump and link, so here, jump and link, and one more. If you look at the RA, and maybe I put the hex back. So it's 0. If I do one more, the RA got 40001C, and then we ended up here. So if you look at this address, 401C, you see that one is here. 1C here. So that's after the jump and link. You see, so it's kind of marked this location that I'm gonna go back after. But that's only if you call the jump register. Does that make sense? So you can actually see that this array is getting updated. And then I want to continue. So if I do more, I should have some jump registers here. So if I go back, I move forward. So there is a loop. Okay, so here, jump register, and you see this 4001C. And one more thing, I don't know if we talked about this or not. There is this program counter. Do you guys know what is that?
The return address +4.
Well, we have that. Yeah, correct. But so that is like very specific case to when we have functions. But in general, program counter is just a pointer to the current line of code. So that's how CPU knows where it's actually executing. It kind of saves like, okay, I'm currently running line 1. And then it does its stuff. And then it's going to check, okay, where am I? I'm line 2. Okay, let's do line 2. So that's how it works. It's basically save the current line here. And every time it's incrementing it. So this is our return address. This is our program counter. That is like the current line. And you see it here. That's the same address here. And if I go one more, we had the jump register. So now they're the same. So it went back to that 1C. Does that make sense?
Yep.
Yeah, and then just one more thing. So forget this jump and link. I just want to show you the program counter. So if you just look at the program counter, so it's like 004 and it's like 8. I'm just doing one line. C 10 or 110, 14, 18, you know. So that's basically every time it's incrementing by 4. Okay, so that's that. So here we are. So this is the first then. So we call this one time. And now we're gonna save that return value to S2. So we could have that. So S2 is equal to that. Okay. And so this part we are just printing, right? So we are putting the V0 into A1, which we could actually do S2 also. I would rather to do that. And then we are putting 1, which is that, I think, printing that we had into V0 to just put the signal, and then we're doing system call. So it just prints, print the result, this one. And then we want to print a space or a new line, and that end line is basically defined here. So that's a new line. So we're here. So we're printing a new line. And now we want to do this again. So we want to call the function for a second time. So if you look at the C code, so basically this was, so far was this part only. So we did the power, we printed the results. So now we have to do it again. So if we go back, we are putting the two arguments, basically the base and the power, which is this 2 line. So we had in S3 and S4, so we had this saved here. So we are just putting those into A0 and A1. So let's say like a special case, even if I had here, this was 3, so both of them are the same. I still have to do this again, right? Because once I come back from the first function call, which is this one, jump and link, I don't know if that A0 is gonna be the same, right? So even if like both of them were using 3 for the A0, here I have to do, where am I? Here. I have to do both of them again. I have to initialize both of them again. So that's just something to note. And then pretty straightforward. We put the arguments and then we are just calling that function again. So this time, now we have the result and we are putting it in this too. We just want to save it. We are just overwriting some other value, I think, at this point. Or it's the same one, S2. We use the same one. We lost the previous one because it's already printed. So this depends like what you want to do. And then here again, I would prefer to have S2 and print the integer and then print a new line. And then the exit. So very straightforward. Does it make sense?
Yes.
Any questions on this? Okay, so this part is supposed to be a more tricky part. So let's look at that. So again, the position is important. So that's why we're putting this one after this exit. So this is a loop. So basically, because this is what we have, right? We have this 4 here. That's gonna go arg1 times. And for that, we need to have basically a counter, which is this T0. And that's gonna be, we know when to stop our loop. So that's that. T1, we are using it for product. So that's going to be our final result. So also that means if your final answer is in T1, at the very end, we have to put that T1 back in the T0, in the V0, because that is our return address or return value. So we could use V0 from beginning here, given that we are not calling any other function, because this is a leaf function. I don't see calling any other function here. So I could use V0 from beginning here for product and get rid of this line. Do you guys see that? But if I was calling another function here, like I had some, let's say print function, then I wasn't allowed to do that because we don't know if that function is going to change that value. So, okay, so here again, so we have the result here. This is our I for the counter. We are just checking one time if our I is actually already greater than this A1. So that means, for example, if you give a negative, so if you do, let's say if you do something like pow 2 to the negative 2 or 2 to the negative 5, if you do something like that, it's just gonna skip the 4. So it's gonna go back to the end pow. So we're just checking if T0, which is the argv1 or the power, is actually greater or equal than A1, which is the pow. Sorry, T0 is the I. So if this I, which is 0, so let's do like if 0 is greater or equal than power or A1, then exit. That's basically what's happening here. And then we have our for. So the for, every time we are multiplying the number to the result. So A0 is our base, like the 2 here. And every time we are multiplying that to our the current result or the result that like so far. And we are saving it back to T1. And then after that, we are just incrementing the counter so we can know when we have to exit. And of course, checking the exit for the loop. So if we are still less, so this is kind of like a valid thing. So basically it's that. So here we are thinking like, when do we have to start the for again? When do we want to start the loop again? If this condition is still true, right? If it still is valid, let's do it one more time. So we are checking if I is less than that power or A0. And then we are going back and run that one more time. And then it's straightforward again. So we have this answer that is calculated. We just put it in V0. So the other or main or any other function, they can get their result. And then we are jumping back, doing a return. Basically, yeah. Any questions on this?
So if pow is a nested function, should we still use T0, T1? Because when it calls another function, the callee might also use T1 and T0, right?
Yeah, I like that question. So let's make it an instance function. Let me, or I can just copy this. Let's do a print, right? So we have, where do we have a print? This one. I mean, print is it's not a really like a proper nested function. I mean, it's very small, so it's nothing changing, but it's valid. So let's do that. Let's say we are doing actually we don't need A0 because already they are putting A0, right? So A0 value to print. I'm gonna get rid of this. So basically that's our print function. And on my loop, I like to put, let's say, so jump handling print, but then I want to put A0. So what do we want to print here? Let's print the current value so far. Sounds good. So this T0 is the current answer so far. I'm gonna do basically move A0 and this thing here. Right, this is our current answer. So this is gonna change like a lot of things, but let's try. And then let's do one new line also there. So this is gonna print the number and print a new line after that. And then we want to not forget to do this because it has to go back. All right. So right now, if I run this, this is gonna print, but then here it's gonna be messed up, right? Because I changed A0 and I believe A0, I'm using it for, where is the multiplication here? Because that's our base. So we are actually using that. So I want to run it still and see, and then we can fix it. But do you guys so far see what I did? So it's just a new function, print a number, print a free line, and jump register. And for this new function, I have to put A0 to print. So that's the value that I want to print. So I decided to print the result, the calculated result so far. And to make it simple, let's get rid of the second function call here. So this is the exit thing that we have. I'm just going to copy this one right after we call the function one time. So basically, I'm skipping all this for now. We are just putting, let's say, 3 and 4, or make it more simple, even 2 and 4 onto our A0 and A1, and I'm calling POW. And that's it. And then I'm ending the program. So if I save this and assemble and run, we're gonna, so that's the old thing. So we're seeing 1, 2, 3, 4. Okay, 1, 2, 3, 4. I was expecting it is 2 and 4. Oh, because it is gonna change. Okay, yeah. So you see that this is not our result. So what happened here that we lost A0?
You're just printing the counter, right? T1 from 1 to 4.
It is 1 to 4, but because we put a T0, so that's our. Oh, sorry, I'm putting the counter. What is our answer? The answer is T1.
Yeah. Oh.
Okay, but still it's gonna be messed up because then our multiplication gonna be messed up. So what I'm getting now this time. So you see, I'm getting like weird answer. Here it is. Okay, so it did run for 4 times, but I got 2 and then like this weird number and then 0, 0. So if you are just looking at this, like without knowing how the function works, it's very difficult to debug because, you know, but basically if you want to do this, and this is very valid, right? You want to track your, basically your multiplication as it's going. It's a valid case. Like I want to see what is the result I'm getting every time the loop is going through. So how can we fix this? So think about that. We are basically here, we are messing up something, right? We are putting T1, which is our current result, into A1. But I need A1 because, well, here I cannot change this, right? Because this function takes A1. Like that's non-negotiable. All right, this function has to take A1. That's the argument. But by putting this here on A1, I'm losing my original A1, sorry, A0, which is my base. So I'm losing this 2. So what is the solution for that?
You can move it to another register.
Yeah. And which register would that be?
Would it be safe to move it to an S register?
We have to do a S register, right? So I've seen before, like people answer, like for example, sometimes I get the answer that let's move it to the stack. So that also, I just want to say, for maybe other people watch the video later. So that also works, moving to a stack, but it's kind of extra work, extra unnecessary work at this point, because then every time you have to like basically read from the stack. So we don't want to do that. The best option is doing, as you said, the S registers, because even if this function is doing anything, and maybe we can like quickly do that, still we are like kind of sure, we are guaranteed that if this function was kind of like written by a sane person, if they are changing the S registers, they are restoring their value. So that's kind of like the argument or the agreement that we have. So this function, like, yes, I can change here. I can put like, you know, li s0 5 as a function. I can do that. But if I'm doing that, I'm kind of promising that I could change this. But if I want to change it, I'm gonna save it to a stack before, and then after I'm gonna restore that value. So if you are looking from here, from this function's perspective, or from here, you're not gonna see that your S is changed ever, because that function gonna maybe change it, but restore it. So that's why it's a safe choice. So what we can do, so at the very beginning, let's, so here we don't have any, oh, there's another issue. Okay, but let's talk about that later. So let's do a move. What I want to save? I want to save T1, right? So instead of using here, so instead of using T1 at all, I'm just gonna change this to like S0, because I define that value. I mean, I could do move S0 T1, right? But that T1, I defined it. So from the beginning, I'm gonna put it in S0. So if that is S0, so all the T1s should be changed to S0. So T0, T0, it is gonna be S0. I'm sorry, I'm doing something wrong, which we need actually, but here we are changing A0. That's what I want to save. But these ones also we have to save because we are calling a function. So let's save S0. So move here, this one, S0, and then A0. Did you see what I was doing? I kind of confused saving this one. So I'm overwriting here. I'm copying T1 to A0. So I'm losing the A0 value here. And A0 is our base. So I want to save that basically in S0 before doing that. And then I can then write in A1, doesn't matter. But I'm gonna use, instead of A0 here, then I'm gonna use S0 for my multiplication. Do you see that? Did I lose you?
Oh, yeah, I see it.
Okay, so basically I was replacing my base, because my base here was stored here, you see, on A0. So by putting this number for this function in A0 again, I would lose that A0 that I had before. So I'm changing into S0. So if I now run this, so by the way, let's put before we go too far. So this is like a to-do, save S0, restore. So we cannot just change S0 in a function, right? Because I'm in a function. It is not a main. So that means if I'm doing this one, I'm gonna mess up this S0 here, the original S0. You see that?
Yeah.
Yeah, so we are in a function. So I'm temporarily doing it. I'm gonna run and see, but then we have to save and restore this one. So let's run and print. So it did better this time. So I'm getting actually 024,816 because that print is working kind of. So every time I'm going through my function, I am, how do I say that? I'm looking for a good word. Like that's the results so far. I'm printing the results so far. So this is working, but now because we changed this one, we have to basically save it on a stack and restore it. So that's one thing. The second thing is that now let's do something else. Like let me see. So just doing this one actually complicates a lot of things. So I'm gonna say basically a few things that is complicated now. All these T registers I cannot use anymore here if I need to hold the value because I'm calling another function. So that's one thing. So this should be all S now. And then other thing, I'm calling another function. So I'm losing my return address also. So this return address here that I'm jumping back. So I don't know if I can do a nice drawing of this. So let's say we have main calls POW, and then POW calls print multiple times. So we're going multiple times here. So this is the return address right now. The return address, when I did the main, was like somewhere here in the main. So this was safe. But as soon as the POW calls print, so now the return address is this location after POW. So I cannot go back to this anymore. I lost this original one. So this here, I don't have this return address anymore because this one overwrite that. Does that make sense, or I'm confusing you guys?
It's a little confusing.
Makes sense.
Okay, let me put it in a different way, like a simpler way. What are the things that we said? So we have to, we cannot use in function here is this T1, T0, if we want to keep the value. So if I have T0 and I'm calling this function, this T0 cannot be before and after could change, right? So easy fix, let's not use T0, let's use S registers. So I'm gonna use for instead of, so same thing with T1 also, right? Same rule. So it's very easy. Put everything in S. So here, instead of T1, I'm putting S1. And let's replace those. So T1 here, S1. This is S1. And that's it, right? Or this one. Did I get it all? Yes. Instead of T0, let's use S2 because I'm calling another function. I cannot use that. I could use that if I was doing something here with the T and it was done. I didn't need the value after. But because it's a loop here, I do need the value. So this was T0. I'm just changing it to S2. So T0, 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 and another T0. Did I get it all? I think I did. Okay. So that's the first change that we did. And then the other one is the return address. But so far we should run this and we should get, if I replace everything correctly, we should get the answer. because we are not worried about here yet. It's basically the original one. Like I'm changing these S values, which is not okay, but like I know at this point that this is all my main. So I'm just calling this function and that's it, it's gonna end. So if I run this now, let's see what we get here. Print. So we are getting, yeah, 2, 4, 8, 16. So it's actually printing those. And it's doing it a couple of, I think, of this before, I'm not sure. It might be a infinite actually, if I make this slower. I think we are running into an infinite loop. Maybe a bit. So 2, 4, 8, 16. Yeah. Do you see that? What's happening? So it is an infinite loop actually. So it's going from jump register to this line BLT. Can you say why? So it's going from here to here. And that's an infinite loop.
Oh yeah, oh yeah.
Do you see the problem?
You have it on the for loop?
Okay.
In the for loop, is that why? Because it's linking print, or
Okay.
it's trying to.
So the for loop goes fine actually. The for loop goes, but then it exits from the for loop. So it gets here and exits, and then it's going through these two lines. It's jumping between these two. So it goes here and then goes back here on this again, and then go like that. So the for, let's trace the for. The for is, we are using S2 as a counter, right? S2 is the I. So S2 starts from 0, and then we are doing add I, S2, S2, 1. So S2 is our counter. So let's look at that. If I clear everything, where's S2? So here is 0. And make this slower, maybe print. Okay, S2, so it's 0. Still 0, 1, 2, 3, 4, and it should, you see, it stays at 4. So it seems that the S2 or our I, which is the counter for the for loop, is doing its job. It's going from 0, 1, 2, 3, 4, and it will stay there because 4 was our limit, right, on the original code. Pause this one. So 4 was, basically it was 2 to the power of 4. So it did actually run 4 times. But it still is getting stuck. Any other idea?
Is it because the return address is overwritten?
Exactly. We lost the return address. So when I call this one, what is gonna be my return address? It's gonna be like line 87. After I come back from print function, I have to be here. So the original return address was on the main. So after this pop. So the original return address was like line 25. But once I call this, that's the second print, now my return address is 87. And so I do go through my loop, and that's fine because it goes back, and then I'm calling print again a couple of times. It's fine. Every time it works. So the print works fine. But then once I want to return from this original POW function, my return address is not here. So when I return from the POW, I actually jump back within POW. I jump back next to the line after print. So then this gonna jump back here and check the for loop. Can I run the for loop? No. So it put this value again. It doesn't make any sense anymore. And then it returns back again here. Check the loop, and then again. So it just repeats there. Do you see what happened, everyone?
Mhm.
Yeah. So like a quick fix, which is not the right fix. So if I want to just, do I have any S? Let's use S6, for example. If I do move S6 and then RA, so here I have some return address. I'm gonna put it in S6. And then I'm gonna put jump register S6. So this should go back now because I'm saving the original return address. Or I could just to return it here. I could do, for example, move RA S6. There is bad practice. I'm just putting it for a quick show, like a quick basically run. So if I now run this one, let's go a bit faster. So we get 2, 4, 8, 16, and program is finished because it did went back to that main, which is the 10 system call. Do you guys see that?
Yeah.
Okay. Yeah. So that's it basically. So how to fix it properly? All we have to do now is to save these things on a stack instead of so the return address. I mean, nothing stops me from doing this one, but it's just a convention that you don't need to waste extra register for that. So this return address also going to go to a stack. So I'm going to remove this one. And I'm going to keep as return address here. So what am I using here? S012. Yeah, so that's the tree. So I'm using, so what I want to save is S0, S1, S2, and then return address. So these are the things that I'm using here that I'm not supposed to use because maybe on the main, we were going to use it again, this S registers. So if that's the case, we are okay, you can use them, but we have to save them. So how do I save? We said that it's the from register to the memory. So what is the direction? Is it load or is it a store?
Store word.
Store word. What are we saving? Let's think about, like, for example, S0. So that's gonna be 1, and then we are saying it in the stack pointer. So SP. So I'm just gonna copy paste to make it easy, and then we think about to make it right. So this is what are the things that I'm saving. So I have these S0, S1, S2, and then RA. So we are saving this one. Where should I save them? So the current stack pointer, it has some value. So that's the convention. So it's the memory. The stack pointer is pointing here. So that has some value. So this is like something always. When the stack pointer is pointing to something, we assume that that's a valid content. So where I want to save to the next available spot, which is basically offset of 4. So I'm gonna do then, what should I put here?
-4.
-4, because the stack is just backwards. So -4, -8, then -12, -16. So that's that. And then I have to update the stack pointer. So I put here like 1, 2, 3, 4 values. So this was -4, 8, 12, 16. So now the stack pointer should move here. I can move it basically -16. Right? Yeah. So that would be add I, stack pointer, -16. So this gonna save those values. And then I'm gonna use them. Perfect. And then last thing, I am going to restore those values. So I'm gonna actually copy paste these here. Let's see how we can fix it. So first it's gonna be load words. And the first one, so where is S0? So S0 is basically here, right? Because it is important not to load them in a different direction, like basically putting S0 here and then loading into RA, for example. So S0 is here, S1 is here, S2 is here, and then RA is here. And the stack pointer is currently here. So if I want to do the same thing, what I like to do, I mean, you can just think logically and figure out, but what I like to do, I like to always put the stack pointer back. So I'm going to put the stack pointer back. So I went -16, now I'm going 16. So now the stack pointer is here. So I put it back. And then the next thing, let's do, well, S0 is -4 from the stack pointer, right? Because the stack pointer is back. S1 is -8. And S2 is -12. RA is -16. So it looks good to me. Sounds good? Yeah?
Yep.
Clear? Okay, so if I clear this, and then if I run it again, I should hopefully stop the program. A bit faster. 16 and finish. So no problem for the losing the address. And then let's just do a sanity check. I'm gonna remove this one. So we're gonna run the second time also. I'm gonna make this faster. Oops. So 248, 16. That's the final answer, 16. And then 39, 27, 81, 243. Yeah, there you go. So this, the second value, the print is actually from main. It's not from the from that function, from the POW. It's actually coming from main. That's why there's 2 times. Yeah, so that's it. Does that make sense? Any questions on these? I think the best way to deal with this is that basically write your function as you're writing a brand new program. So just do the way it should work. And if you are calling other function within your function, just use S registers. You know, so just use that. And then just you add this. That's it. So you shouldn't worry about any losing value or conflict or anything like that. Yeah. Any questions? Anything else? If you guys any, I don't know, any other topic? I take that as a no.
I'm still kind of going over like the pointers, but it definitely cleared up a lot.
Yeah, so for the assignment, let me look at the assignment again. What do we have? This one? No. Print value, loop printer. Actually, that is very, very simple. I'm definitely like considering the current example. If you look at this one, they're very similar, many things. The only thing, like, don't put in this order, put the main on the first, or do a jump. But I think it's better, just keep the main first, and then make sure at the end of the main, you do have that exit.
Yeah, I think that's where I was getting confused because I was writing the code. I was attempting to write it in the order that it was on the assignment, but once I did what you said, like moving the main and registers, like adjusting them, I was getting a better result, like closer to what I need to be getting instead of all these extra
I see.
processes.
And then other thing that I recommend is that, like, without losing your code, because it could happen, like, just copy everything or make a new one and just put this function, for example, in that, and then run that. So make sure you get the right result. Just just this function. And then separately, like, write the code for this one and then see if it works, like everything is okay. And then once it's okay, then, kind of like you can debug them separately, basically what I mean. Yeah. Other than that, I mean, here, okay, so we have S0. So I think that's one tricky part so we have S0. See, on purpose, I put this S0 here and here, because this is on the C++, there is a local scope, right? So this S0 is not conflict with this one. So C takes care of that. But the reason I put, because you need to have this on, let's say, S0 or any S register, because you're calling this print function. So basically, this is what we had, I think, T1 or T0. So that's a counter. So because you are calling another function, you should have this one in a S register.
Yep.
And then size. So here, what is going to be size on your assignment?
Size is going to be S0.
Well, initially. Well, how you pass it from here? Loop. How do you pass this one?
Oh, you're going to link it. So you're going to move S0 to A0 and then pass it through.
A0, yeah. So this is going to be A0 at this point. But here also you have to put something in A0 because you're calling this other one. You see? So this is on A0 when you initially get this. And then here also it's A0 because you have to put something in A0 to call this function.
So would you just move? You would just move A0 to another S. Well, so does it have to be S0, or could you move it to an S1, the pointer?
Yeah. So any S. So any S is gonna be saved between the function calls. So S1, 2, 3. I think you have till. How many we have? We have 7.
9. Not. Oh, 7.
Yeah, T's are going to 9. Yeah, so including 0. So you have 8 S registers. You can use any of them. So basically you move that one into S register. So this is already S0. So maybe you move this one into S1. And then yeah, we don't even have a result here. So your return address is just from S0. So yeah, so that one is just simple. So you just, at the end, you just add S0, whatever you have to 10, and then return that. Put it in V0 to return. Yeah. Yeah, and then here is basically the A0. You don't need to change it. So it's gonna be similar like that because only this 2 line for just to print a number, because it's already A0 is in the whatever, is it V0? So A0 is already well, A0 is already the number I want to print. And when you get to that function, you already have that because you put it here to call this function before jump handling. So you have that A0 here already set up. You just do the 2 strings. So like what we have here. So that's the end line. And then you have basically 1 before that for the number is. And then in the middle, you have basically this thing to just print that number. So normally you do something like that, right? A0, 5 to print 5. But in this situation, this 5 already is on A0 from this location. So this one is like the easiest one.
Don't we need to save a copy of A0? Because when we do the print string, it override the address for A0.
Oh, you're right. You're absolutely right. It is an A0. So the print string is gonna remove that A0. You're very right. Yeah. So then that could be interesting, but you don't need to do a stack still. So
Yeah,
what I
in my
would do,
case, I save A0 in a T0 because
Yeah.
it's a lead function.
yeah. So you know that this system call is not changing that T. So yeah, you do basically A0 to T, and then this one you do T0, something like that. Yeah, you're right. Yeah. So I just did your print function. That is, yeah. But other than that, did you get the answer, or is it okay for you?
Yeah, I think it answered my question.
Okay.